I forgot to turn on record. And these are both equivalent, so you can use either one. So what would the equivalent, say we were doing nanograms now. How many nanograms are in 4.6 grams? Okay, so same thing, what's given? What are we calculating? This time nanograms. Well, how many nanograms are in 1 gram? How many grams, how many nanograms are in a gram? After micro comes nano, and it's always by 3 decimal points. So it's a billion. So there's a billion nanograms in a gram. So there's a billion nanograms in a gram, or 10 to the minus 9th grams in a nanogram. So grams got canceled. So there's 10 to the 9th nanograms in 1 gram. So what's the answer to this problem without using your calculator? Yeah. 4.56 times 10 to the 9th nanograms. Yeah. So both of those are conversion factors. You can use either one. They're both equally as valid. And then we also have the inverse. So there's 4 conversion factors there that convert nanograms to grams. Now, when you look at these conversion factors, another thing you need to do is say, do these make sense the way it's set up? You know, a nanogram is even tinier than a microgram, 1,000th tinier than a microgram, really, really tiny. So if you have a whole gram, you better have a whole bunch of nanograms. So 10 to the 9th is a whole bunch. So that makes sense. 1 nanogram is really, really tiny. So when you go 10 to the minus 9th, that's a tiny, tiny, tiny bit of grams. So that conversion makes sense. Should make sense to you in your mind just by looking at it without doing any math. I want you to get used to your relying upon your senses. Does this answer make sense? Oh, one other thing here. How many sig figs is 4.56? What about 10 to the ninth? No. Tricky question. No. Why? That's correct. Why? Now, if you're adding zeros at the end with no decimal point, they're insignificant, remember? So how many sig figs is 10 to the ninth? Either. When, remember, last Friday, we talked about sig figs. I gave you all those rules, right? With a zero in the middle, the beginning and the end, and decimal point present. And then there was an exception to all that. What was the exception? Huh? And when is it infinite? Yeah, by definition, exactly, yeah. And this is by definition. So 10 to the minus 9 nanograms over 1 gram is infinite significant figures. Hence, it doesn't enter into the calculation. Hence, your answer is going to be 3 sig figs. Okay? So anything on that table, metric-wise, is infinite. It doesn't come into play when you're counting sig figs. And the bold-faced ones are also by definition. So those are infinite. And one that's not included on there is 1 milliliter equals 1 gram of water. That is until you get to Chem 1A, then it's not quite that. But as far as our class is concerned, 1 ml, 1 gram, as long as it's pure water. If it's not water, it does not apply. It's water only. Okay. How many square inches are in a square kilometer? Okay, is kilometer big or small? Big. And as you know, inches are small. So we're going to have, so our answer is going to be a whole bunch of inches. So we get our numbers, make sure that that's consistent. Okay. So we're looking at, in fact, let's make it, so that's what's given, or to calculate square inches. Oops. Okay, so remember now we're talking about square stuff now. So you got to use the squared conversion factors. Okay, so we have kilometers, kilometers, either way you want to say it, and we have inches. Do we have a conversion form that goes directly from square kilometers to square inches? No, so we've got to put together a series of conversion factors to get us from kilometers to inches. So let's look at our conversion factors up here. One-dimensional ones to start with. Okay, so we have inches and centimeters, and centimeters are just a different way of saying kilometers with a couple calculations. We have that. We have meters to feet, and we have kilometers and meters. So what do you think we should start with? Kilometers to meters. Now remember, it's square kilometers to square meters. How many square meters are in a square kilometer? Remember how we did this before? If you start with a one dimension, you're going to square it. So when we square the m, it becomes m squared. When we square the 1,000, we have to square that too. Okay, now we have square meters. And our kilometers cancel. Remember, the given has always got to cancel, no exceptions. All right, now we have square meters. Where are we going to go from there? Remember the, okay. So how many square feet are in a square meter? Well, how many feet are in 1 meter? Okay, we just go up to our handy dandy conversion table here. .328 feet in 1 meter. Now, notice that is not bold-faced. That means significant figures, because it's not by definition, okay? So that's an approximation, 328 feet in 1 meter. Okay, now we have square feet. Now we need to go from square feet to square inches. So how many square inches are in a square foot? 12 squared, or 144. Okay, so notice everything cancels out except our square inches. What are we trying to calculate? Squared inches. So our setup is correct. And remember, if this was on a test and this problem's worth 10 points, that's 9 points without picking up your calculator. So we're looking at 3 sig figs, infinite sig figs, 3 sig figs, infinite sig figs. Okay. Now the infinite ones are by definition, or they're bold-faced in the conversion chart. All the others, we just have to look at the numbers and calculate the sig figs within that number. Okay, so to do this, it's 112 times 1,000 squared. So that's 1,000 caret 2 times 3.28 caret 2 times 12 caret 2. Oops. Now, it'd be good if all of you do this calculation right now. Make sure you get the same answer I did. So it's 1.74 billion square inches. Now, kilometers, good size, smaller than a mile, but it's still good size. So kilometer by kilometer, you have a whole bunch of little square inches in there. I'm sorry, what?
God, why not? Oh, because you don't need to spread out.
Right, exactly. Because that's what we're starting with.
I just saw that there's a 2 over the KM. So that's what
Yeah. The km squared, because we're starting with square kilometers. Okay. Now notice this is a 3-step problem. You're going to have a take-home problem that I'm going to post. Could someone send me an email to remind me to post the take-home problem? Yeah. Explain how I got what? Okay, I took 1.12 times 1,000 caret. What kind of calculator do you have? What kind of calculator? What brand? Texas? Okay. So you're going to go caret. A caret looks like this. So it'd be this is the keystrokes. Yeah. I mean, the 1.12, because that's given. If we square it, it's not going to be given anymore. But the km is squared though, the square kilometers. Okay, so those are the keystrokes. Now, on your take-home test problem, it's going to be long. It's going to be lots of conversion factors. So the strategy is what's given, number one. What conversion factors do I have available to me? And what you're going to have, I'm going to have a sheet of assumptions. And those assumptions are going to have, a whole bunch of conversion factors on it. Assume this, assume that. For example, in the world in 2014, what was the average family size? 2.3 people per family. So there'll be conversion factors. You wanted to convert families to people. Now, the page is going to be a page and a half of assumptions, a whole bunch of them. And you're not going to use all of them. You're going to go through there, just like we aren't using all the conversion factors for the metric system in this problem. We only use a couple of them. You're going to go through all the assumptions, and you're going to pick out the ones that are germane to that problem. And you're going to ignore the rest. There's going to be a whole bunch on there, like the square footage of Africa, or the size of Africa in square miles. You may not need that, so you ignore it. Or the ones with the families you might need. Okay, so I need for someone to send me an email to remind me to post that problem. And it'll be under modules, test related. Test related. Test related. There should be a practice one there, which was last semester's problem. Yeah. You're going to turn it in. You're going to turn it in when you turn in your test. So you'll bring it completed. Yeah. Or you could just write it on a piece of paper. But the main thing is, I want to warn you, it's got a whole bunch of little parts. Whole bunch of little conversions. That's why I'm giving you a week to do this problem. And it is a test question. It's not a group question. Keep that in mind when you're doing this, okay? Now, I like to do real practical problems or take-home problems. And this will be a real practical one. Yeah. Not quiz one. It's part of the test one. Sometimes I have quizzes, sometimes I don't. We're not going to have a quiz tomorrow. Sad face, I can tell. Yeah. Correct.
When we turn the other part of this?
Yeah, the other part of the test is in class.
Yeah.
So when you give me your test, you're going to staple the back, take home. So, and I know every test does not have a take-home test. Test 1 and test 4 have take-home problems. The rest of the tests don't have. Okay, we're done with unit 1. So starting tomorrow, we're going to start unit 2, which we're going to use in the periodic table and all kinds of chemistry. For God's sake, why haven't we're in chemistry class, right? Why aren't we doing chemistry? All right, so we're done for today, unless you have some questions. And then in lab, we're going to practice doing a lot of these problems. Now, again, some of you said, if I already know how to do these, can I do these at home? Yes. Not a problem at all. But I would suggest for those of you who are struggling with this concept, definitely go to lab. I'll be there until you're done. That's the beauty of these dry labs. Okay, so I need to pick up all this junk up here, hardware wise. And I also have to convert the video file into an MP4, which takes a couple minutes. All right, I'll see you in lab. See you later.
But